So beginning 5.8 is just a reminder that make sure that you are paying attention to radians, solving, and don't forget that you can have more than one correct answer. So there's a lot of different tricks that we've done, and as a reminder that we're going to hit the inverse sign button in order to solve for theta, except your calculator can only find one answer at a time, which is why in the previous unit we talked about how to solve some of these. So here's just a reminder. What I'm doing is taking the inverse sign of both sides. That way the inverse sign will cancel out with this sign. You're left with theta. And for right now, I just want you to go to your calculator. And if you see degrees, then we're in degrees. In this problem, we're in radians. So as you go to your calculator, clear this out. Make sure that you're in the proper mode. So you might need to switch back. And then second sign of 0.523. And we get an answer of 0.550. Now remember, that's your answer in the first quadrant. Somewhere in here, that's the angle that's being made right here. So you also have to think about where else is sine positive. Well, sine is also positive in the second quadrant, and the reference angle is the same. So think about, okay, well, if you went a full half circle revolution, that would be pi that you would want to subtract off at 0.550. Now, as I type that in, I'm going to make sure you hit the pi button. You do not want to round, and then minus the answer that you just got. Because again, if you round it, you might be off slightly, so 2.591. So those are your two answers, 2.591. All right. Now that's just for one revolution. It gets more complicated if we have a double angle. And the reason why it gets more complicated is because if we want answers for theta between 0, so let's say theta is on the interval from 0 to 2 pi, including 0 and not including 2 pi. It's typically how math books will write it. Well, if you were to double theta, let me think of it this way. And theta was just between 0 and pi, 0 and 2 pi, and then later we double it, then there's a second rotation going around it. So the premise that's happening here is you actually want to find, when you do this step, that 2 theta is equal to the inverse sine of that value, negative 0.792. You actually want to find it as if you did 2 revolutions. And it'll make more sense as we do more problems. But I'm just going to go to my calculator real quick and hit inverse sine of negative 0.792. And we get an answer of negative 0.914 radians. And what I'm actually going to do is I'm going to hit the store key. I want to reference back to this several times. So if you hit the store key, and I'm going to just pick one of my green letters here, so like alpha A is exactly what those keys are used for. Anytime I want to use A again later, this number, I just have to use that value. So for instance, if I want to do that number plus, pi, it'll take that negative 0.914 and add pi to it, and things like that. So the reason why I'm going through that is that, first of all, that's not bigger than 0. So let's think about that for a second. Well, if we had a negative angle, what that means is that we went clockwise. So what I'm going to do first is establish that angle as if I wanted to go clockwise, so I can fix that by adding 2 pi to it. So I'm going to take A and add 2 pi to it. Whoops, that is the wrong button. So 5.369. So I actually don't want that value. Oops. I also want to think about what if I had this angle right here, because again, sine is negative right here. The reference angle is that negative 0.914. So what I'm going to think about is what if I did the absolute value of that number, which again in my calculator is A, and I add pi to it. Well, I can do, if you didn't know, in the math key absolute value, you do have that as a is capable. Your calculator can do the absolute value. And you get about 4.056. Oops, I wanted to write that here. How about we go in order? But then I also want to do a second revolution, so I can add 2 pi to that value. If I add 2 pi to that value, you get 10.339. And I also get, I want to add 2 pi to the 5.369 that I got earlier, this value, and add 2 pi to it. And 11.652. So here's the real reason why we're doing this today as well, is because by doing 2 revolutions, we want to do 2 revolutions because later we're going to solve for theta by dividing by 2. And you have to divide every one of those values by 2. And the reason why we do 2 revolutions is because 2 pi is about 6.28. I just know 3.14 doubled. And by dividing each of these by 2, we're going to get all of our answers smaller than 6.28. That's why we want to do 2 revolutions. So the number that's right here is telling you how many revolutions you need to do in order to solve. I think I'm going to cheat for a second. Just go to the answer key, because I trust that you can use a calculator to divide. And this is actually where having a graphing calculator is useful, because then you can actually, just hit that number divided by 2, and you get 5.826. You can go back to this number divided by 2, you get 5.169. But as I said, I'm going to go to my answer key, which I did not prepare well enough for you guys. That you can see, I don't know what I just did. Sorry, I just did an answer, a button, and a bunch of things happened. But as you can see, he actually did one at a time, which in hindsight I probably should have done as well. And maybe I'll do that on the next one. Where notice the very first step is doing that inverse trig function, but you want to do 2 revolutions. And then you divide everything by 2. So you have 2 thetas equal to some number that you divide by 2. 2 thetas equal to some number you want to divide by 2. 2 thetas equal to some number divided by 2. And so on and so forth. So if at any point I'm going too fast, don't forget that you can hit the pause or rewatch the video. So first of all, to solve for tangent, because it's not on the unit circle, you want to practice the inverse tangent. And as a reminder, that the answer that you get is going to be negative, so that means we're going clockwise, but we only want answers for theta bigger than 0 and smaller than 2 pi. 2 pi is about 6.28. If you want the exact value of 2 pi, you just type that in. 6.283 would be a better approximation. Yeah, so second tangent of negative 1.258. So negative 0.899. And we don't even want that angle because that's not bigger than 0. So you can fix that because tangent's also negative in the second quadrant, so you can add pi to that. So the first thing I'm going to do is add pi to that value. So you get 2.242. So 2 theta is about 2.242. And then when you divide by 2, you'll get theta. And remember, I like to round to 3 decimals, but it's 0.121. 1.121. But as I mentioned before, you want to start back over. So what I'm going to do is go back to this value. And I'm going to add another pi to it. Because remember, 1 pi is a semicircle. So if I go back to my picture, adding a pi to it will take me back into the 4th quadrant, which I hope you would all agree that 5.384 is about in the 2nd quadrant. Sorry, is about in the 4th quadrant because it's slightly smaller than 2 pi. And then so that's 2 theta equals 5.384. When I divide by 2, you get 2.692. But that's only doing 1 revolution. Because this number right here is 2, we need to do 2 revolutions. So I'm going to go back to that 5.384 and add another pi, another semicircle, 8.526. And you might be still asking yourself, why are we still doing that? Because now when I divide by 2, I'm back underneath 2 pi radians. So 4.263 radians. And I should, I'm just nervous about my timing, 8.526. But that's not even all of 2 revolutions. I need 1 more, which would be another pi to this value. 11.667, and when I divide by 2, gives me the last answer, 5.834 for theta. Alright. So we are going to practice a little bit more, but I think that's a good place to stop. Let me go back to my work, even though I was really nervous about time, so that's why I didn't write down my answers here. So maybe I'll share the answer key again. Hopefully it's still on the right page. And his work goes in a slightly different order, but you can see that work as well. And I'll see you in the next video.